Hello, for this lesson, we are going to graph using transformations. This is really useful because we do not want to take a lot of time in graphing. And when you make t-tables or plot points, it could take a really long time. And so we're going to talk about two different graphs. First one is absolute value, and then we're going to do quadratic functions and their graphs. Now, the notes are posted on Canvas. So if you want to download the notes, the slides will be there, but also notes in general. So you can print them out, or you can download them on your tablet or your computer if you want to write on it. All right, so an absolute value function. And we're in function notation. So this is f of x. Now f of x or g of x or k of x or whatever of x is the same thing as y. That is going to be your output. You can see for the function itself, it is the absolute value of those bars x. All right, so to graph, we are going to do a table. So if you do not know the absolute value graph, you'll know where it comes from. When you put in values, you always start with a negative first. If you just put a positive and zero, you'll only know it one side, and they're not always mirrors. On the left isn't always on the right, and they could change. So when you put -3 into here, and I can just do that, what happens? The absolute value is going to make it positive every time. So when I put -2 into our function, it's going to come out 2. -1 is going to be 1, 0 is going to be 0. Now what if you put in 1? Remember, absolute value is distance. So the distance from absolute value is distance to 0. So how far away is 1 to 0? And it is still positive. The distance from -1 to 0 is 1. Distance is always positive. So that's going to be 2, and this is going to be 3. So when you graph it, -3 is going to give a positive 3. -2 is going to be positive 2. I'm just going to graph that very quickly. So we can see the pattern. If I put a -4, it would have been 4. -5. So it's going to go all the way this way, up and across. And then this way, all the way across. Okay. So the parent graph, and we call this the parent graph because all absolute value functions will have this shape. It may be moved left, it may be moved right, it may get skinnier or fatter, but it has this shape. So the parent graph has a shape like a V. It could be an upside down V, but it's going to be a V. The key points. Generally, I think of -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. And I'll explain why I'm going to use the key points. All right, domain. Domain are all the possible x values. So here's your x's. So for every x value, is there a number? Is there a value? Yes. Even when I go all the way here to -100, can you put something in? Yes. What about a positive 1,000? Yes. So the domain is all real numbers. Now that's a lot to draw. So in math, we have a fancy capital R. Yes, you have to put these 2 lines and make a big swoopy R. That stands for all real numbers. Now the range are all the y values. So if you're looking here, you have to look this way. So there are values this way and up, correct? So there's something here and here and here and here. But is there anything down here? No. So for my y values, you can see it starts at 0 and it goes up. So it goes from y, because that's what the range is, the y values. It's greater than 0, right? And then it is also equal to 0. And it can be fractions. So if I put in a half, it'll come out a half. 2.5, 2.5. Square root of 5, square root of 5. So this is our parent graph. All right, so I'm going to show you how to graph with transformations using a parent graph. So we can see that our graph here, it's the absolute value plus 3. So the 3 is on the outside of the absolute value. So I'm going to graph the parent graph first in black. So your parent graph, like we said, was -2, -1, 1, 0, 0, 2, 2. So this is our parent graph. So it's saying everything that you do, and I'm going to just do a quick table so you can see what happens. So we can make a conjecture. So if I put in a +3, right, you can see that it would be absolute value of 3 plus 3 is 6. If I put in 0, it would have been 0 plus 3. So you can see that these values are shifting up 3. And 3 was 6. Now, is that true if I put in 1? Is that true if I put in -1? So -1 would be 1 plus 3 is 4. So you can see what happens, it moves every point up, all of these points up 3. So you just moved it. It has that same shape, this point. And each point is going up 1 and over 1, up 1 and over 1, just like it is here. So let's take that and think about here. What about -4? If I had my parent graph, what's going to happen with all those points? Can you guess? That's right. It's going to go down 4. So 1, 2, 3, 4. Every point. So if you know this shape, it's going to stay, it's still going to be a V. So if it's plus, we're moving up. If it was minus, we're moving down. And it has to be on the outside of the absolute value. But what happens if the number's on the inside of the absolute value? All right, so this one I am going to table it so you can see. Let's start with -1. So if I put -1 plus 2, what's going to happen? 1. If I put in 0 plus 2, it goes to 2. What if I put in +1? It went to 3. Okay. So you can see a pattern. So this is probably 2 and 4, -2, and 0. So our parent graph still is -2, 2, -1, 1. So it looks like a line, right? But starting from 0 and going up. This one has a slope of 1, and this one has a slope of -1. So if we take these points that we table, what happens? Well, -2 zeros here. -1 is 1, 0 is 2. Okay, oh, look at that. Well, I need some more points. So you can see, oh, I should have put some more negatives. Is it going to go straight down here? Or is it going to go up? Well, let's look. So if I put in -3, -3 plus 2 is -1, absolute value is +1. -4 plus 2 is -2, absolute value is +2. All right, so -3 gives me +1, and -4 gives me +2. So what happens? So let's compare. it shifted 2 to the left. So this plus 2 shifted 2 to the left. So it's actually the opposite sign. So plus 2, it looks like it should go to the right, but it's actually the opposite. Okay. So what about this? Well, if this is the opposite, so this would be shifting to the right. Now, if I'm correct in that conjecture, okay, I'm doing the parent graph. And no, at some point you're not going to do the parent graph every time, but this will help you to see what's happening and the patterns. Right, so if I do make a quick table here, and I think I'm going to shift it 3 this way, so I'm going to put in 0. So if I put in 0, 0 minus 3, absolute value, it's going to be -3, right? Absolute value, +3. If you put in 1, okay, think 1 is going to give 1 minus 3 is -2. Absolute value is 2. If you put in 2, it's going to give me 1. If you give me 3, it's going to give me 0. And 4, we get you 1. All right, so 0 is 3. 1 is 2. 2 is 1. 3 is 0. Oops. 4 is 1. So you can see it went back up. Okay. So did it do what I thought it was going to do? Yes, it did. So it shifted 3 to the right. So you can see if it's on the inside, just like in here, inside the absolute value, it's going left and right. So this one shifted horizontally to the 3 to the right. All right, so take a moment and write down our conclusions. Right, what's the conjecture? Explain what happens graphically when you add or subtract a number on the outside. So the outside is here. And we use the variable k. And for the inside, here. So write it in your own words. K is moving up or down. H is moving left or right. But remember, H is a tricky one because it's going the opposite direction. All right, so what happens with the negative on the outside? Some of you may know this. So what if we're going to start with -3? So I'm actually going to put it here so you can see. So this part on the inside is 2, but you have the negative on the outside, it's going to make it negative still. Is that going to be true for the -1? Yes. The 0, can you have a -0? No, you can't. And then the 1, right, it's the inside, so that's still going to be negative. So because the negative is on the outside, the final answer will always be negative. The inside will become positive, but the outside will make it negative again. So for this graph, it's going down. So what happens? So there's a negative. So if there's a negative in front of the absolute value, then what? What's happening to our graph? Our parent graph is usually above, right? It's usually up here. And this is labeling x of x. And then the graph is reflected over the x-axis. It's going down. All right. So what's happened if we put them all together? That I have a number on the inside of the absolute value I have a number on the outside, and I have a negative in front. So take a moment and write a sentence of what you think is going to happen, and then graph the function. All right, I'm going to graph the parent graph, just so you can compare it. So this middle point here, the point of the V, we call this the vertex. It's where it changes directions. All right, so did you write your sentence? So if I'm looking here, I know that this -2 on the outside is going to shift my graph down 2 places. The inside is going to do left 3 places. This is going to reflect over the x. So did your sentence have those 3 things? So I'm going to take that vertex point, and I'm going to do what it says. So I'm going to move that vertex 3 to the left. 1, 2, 3, and down 2. 1, 2. Because I have a negative in the front, I know it's going to go down. Because I know the shape of the graph, and it goes 1 by 1 by 1, right? There you are. This is by a transformation. So you can see now that we did all that work earlier, I can do this very quickly. I didn't make a table. I knew what these numbers meant and how to transform them. All right, now we're going to take the information that we used for absolute value, and we're going to do translate it to quadratics. All right, and this is a long lesson. I'm sorry. It is going to be a long video. All right, so I'm going to take our function, and you take your x's and then you put it inside. So I'm going to square -2. That's going to be 4, 1, 0, 1, and 4. So when I graph it, all right. Did I do that right? No, sorry. 0, 0, 1, 1. Okay. Not that one. Okay, so that's what. But what if I did do the 3? Was that in the right place? Well, let's think. 3 should be 9. Ooh, so 3, that goes much higher. Okay. You can see, what if I put in -3? Oh, that would also be 9 because it would make positive. So let's look at this graph. So this is much different than your absolute value, but there's some similarities. You still have this nice turn point, still called a vertex, where it changed directions. It is symmetric like an absolute value over the y-axis. This side mirrors this side, just like the absolute value. But this is not V-ish. This is more, to me, shaped like a U. More U-ish. Now, for absolute value function, the graph is called an absolute value. But for a quadratic, it's actually called a parabola. Which is interesting because the name of the function, the equation, is not the same as the graph. So when you look at the equation, we call this a quadratic, but the graph is a parabola. The key points here are similar. However, oh, I totally graphed that wrong. Now I know why. I'm sorry. I knew you knew. It should be 1, 1, 2, 4. Oh, sorry about that. There we go. There, way more U-ish. Okay. So sorry. Okay. So the key point for this one is -2, 4. negative 1, 1, 0, 0, 1, 1, and 2, 4. So for absolute value, these are the same, but you can see that these jumped, so it's going to get higher. Now the domain, can I put in any x value into this equation? Yes. Negative a million, positive a million, sure. 0.0004, sure. So it's all real numbers. That's our fancy R. Now for the range, it's your Y, and it's similar to the absolute value, correct? Actually, it's the same. It goes 0 and goes up. There's nothing here in the negatives. So the range is Y is greater than or equal to 0. Quadratics. Parabola. All right, so we're going to use the same techniques that we used for absolute value for this. So I'm going to graph my parent graph so you get used to that. So it's negative 2, 4, negative 1, 1, 0, 1, 1, 2, 4. Nice you. Now for the absolute value, it says to shift everything up 3, right? So that's the same thing. Do you see that the number's on the outside of the quadratic? It's not inside with the axis, on the outside. This is going to go up. So I'm going to take every single point and move it up 1. So the block is the parent graph. 1, 2, 3. So it still remains the same shape. So this was like a new origin. See, it's still 0, 0, and it's 1, and then up 1. Here you can see it's 2 to the right and up 4. 1 to the left, up 1. 2 to the left, up 4. So it still has the same shape as the parent graph. All right, so the domain. Can I put in any variable? I mean, any x value. Yep, all real numbers. Now for the range, we moved everything up 3. So you can see now that nothing is below it, right? So now it's y is greater than or equal to 3 because I moved it up 3. Okay. Do you want to try this one without the parent graph? Right, so generally our parent graph would start here at 0, 0. But minus 4 means I'm going down 4. 1, 2, 3, 4. Now our shape is the same. Remember, it's going 1 to the left and 1 up. And it's going to be the same on the left because it's going to be symmetrical. Then it's going to be 2 to the right and then up 4. If you want to draw the parent graph to compare it and drop all the numbers 4, it will be the same. All right, so a minus 4 on the outside brings it down. The domain, all real numbers. The range now, you can see, right? It's now from negative 4 and it's going up. So y is greater than or equal negative 4. All right, so let's look at this one. Where's the number now? The number's on the inside and it's plus. So this is going to tell me it's going to move to the left. 4. So we're going to take it. I'm going to move it 4 to the left. 1, 2, 3, 4. And it's going to have that same shape. 1 to the right, up 1. Same on the left. 2 to the right, up 4. 2. Domain, guess what? All real numbers. range. So even though it's moved to the left, the range is the same as the parent because it's from 0 up. 1 is greater than or equal to 0. Right. So inside I have a -3, so that's to the right. So 1, 2, 3, that's where our vertex is. 1 up, 1 to the right, 1 up. 2, 1, 2, 3, 4. Same thing on the other side. Yeah. Domain, that's right. All real numbers and range is the same as the previous one and the paragraph. All right, so let's look here. We have the negative on the outside. And what happened last time? That's right. Everything reflected. So that's the same thing. It's going to reflect over the x because it's completely outside of the quadratic. Because this is the same thing as that. So if I had a negative number for the x, that will become positive, but this negative on the outside will make it, whatever the result inside the parenthesis, negative every time. So this then makes everything go down, but still the same shape. 1 to the left, 1 to the left, 1 down, 2 to the right, 4 down. And if you did 3, it would be 9. Because 3 times 3 is 9. Domain. Still, I can put any number inside. But now the range, right, it's going down. It's still starting at 0 right here, but it's going down. So it's getting, the y values are getting smaller. So y is less than or equal to 0. Almost done, class. Almost. A few more slides. Right. So let's put them together. Now, if you want to try it on your own, go ahead. And really think about what that sentence will be first. What do the numbers tell you in the equation? So first of all, I can tell it's a quadratic because it has that square, so I know it's going to be a U shape. This tells me left 3. This tells me down 2. I have no negative in front, so this also tells me it's going to be up. So my U is going to be like a cup. So I'm going to take my vertex. It's usually here at the 0, so I'm going to go 3 to left. 1, 2, 3, and then down 2. 1, 2. Same pattern. 1 to the right, 1 up, 2 to the right, 1, 2, 3, 4 up. 1, 2, 1, 2, 3, 4. Oops. Sorry, they're better. All right. Domain. All round numbers, and the range, what's the lowest part? Here, y is -2. So y is greater than or equal to -2. So it's going up. All right, so let's look at this one. All right, it's a minus. So again, it's a quadratic, so it's going to be a U shape. -1, so it's going to be opposite. So this is to the right, 1. This is going to be up, 3. And here's going to reflect over the y. Sorry, x. X. Okay, so I'm going to start at 0, 0. So I'm going 1 to the right and up 3. 1, 2, 3. Big point for my vertex. Now I'm going down. So I'm going to go 1 to the right, but now this time I'm going 1 down. You can go 2 to the right and then 4 down. 1, 2, 3, 4. You can do the same thing on the other side. Has to be symmetrical. And if you want to do the next point over, which is 3 to the right, 9 down, you can. All right, domain, all real numbers. Oh, that one's off. I'm sorry. No, that was right. My eyes. I'm so sorry, class. Let's see. 1, 2. No, 1, 2, 3, 4 here. I think I was off a little bit there. Okay. No, I think I did it again. 1. Oh, should be here. 1, 2, 3, 4. There it goes. It looked funny. So tiny for me. Yes, I should go here. There it goes. Sorry about that. All right, so the range, I know it's going down, so the y's are going smaller, and it's here it's at 3 and goes down. So y is less than, because it's going smaller, equal to 3. So you can see the transformations, if you know how to do them, it's much quicker than making a table. All right, so this form that I'm showing you is what is called vertex form. HK is going to be that new point, that vertex, when you shift it. H, right, the x value is here, moves left or right. Left if it is plus, right if it is minus. And that's what I mean by opposites, the opposite sign. K, that's on the outside, it moves it up if it's plus, and it moves it down if it's minus. So that's the same sign as what you think. If A is positive, it opens up. Oh, sorry. Let me do that the other one. Because absolute value is on this way. So absolute value this way, like that. And if the negative in front, sorry, the A is the negative in front, then it's going to go down. We call it down frown. And these are the different transformations. Now, if you know these transformations, A, H, and K, this will help you with all the different functions. All right, thanks so much for watching. I know it was a long video. Thanks for sticking through. Don't forget to answer the EQ. Thanks. Bye.